Okay, the last two problems in this section have to do with how far you can see from a given height. They give this equation d equals square root of 2h. The d in here is the distance in miles that you could see. The h is your height, like your altitude, your height above the ground. Okay, this question, example 6 on 646 says, how far to the horizon can you see through an airplane window at a height or an altitude of 30,000 feet? So the height is 30,000 feet. Okay, 2 times that, and your distance would be in miles. Do 2 times 30,000, 60,000, and the square root of that is? What is the square root of that? It's going to be approximately
245.
245, and what's the unit?
Miles.
The distance is in miles. So if you're at an altitude of 30,000 feet, when you look out at the horizon, you'll be able to see 245 miles away to the horizon. Okay, we'll do one more like this, and then we'll go to the next section, 8.6. Example 7 on the same page. It says, how far must a ranger station be in order for the ranger to see out to a fire on the horizon that is 15.4 miles away? So what part of the equation is this? That's your distance. Your equation, bless you, was, your equation was 2h, square root of 2h. This is our distance, so we put it on this side. 15.4 is our miles. So we need to know how high he needs to be to see that fire, not just the smoke, the fire. Okay, so how high does he need to be? What are we going to do to solve this? Yeah, we need to get rid of the square root. We're going to square both sides. So I'm going to need somebody to square this for me. This will get rid of that whole square root sign, so we have 2h. What is 15.4 squared? 237.16. Now to solve for the height, divide by 2. So the ranger has to be at a height of 118. 118.58.
Gives you approximately 100.
About 119 feet high. You're not going to make sure the ranger's 118.58 feet high. About that high. That's how high the ranger needs to be. Okay, now we're going to go to 8.6. Applications with right triangles. So we're probably going to be using the Pythagorean theory a lot, right? Applications with right triangles. That's a shorthand of writing it really quick. You put RT for right, and we're triangles like that if you'd like. Okay, a quick review on how to do the Pythagorean theory. You have your legs here and your hypotenuse here. Hypotenuse is across from the right triangle, or the right angle. And you usually call the two legs A and B. Hypotenuse is C. You would have A squared plus B squared equals C squared. And we're probably going to be using this quite a bit here. Okay. To find, first of all, let's just play with this Pythagorean theory. Let's do, if we don't have if we don't have the hypotenuse. Let's say we have a 4 and a 5. We need to do 4 squared plus 5 squared. The hypotenuse is always the one that's by itself. We go 4 squared plus 5 squared equals c squared. What's 4 times 4? 16. 5 times 5? 25. 16 plus 25? 41. So the square root of 41 is what? 6.4031 or whatever. 6.403 is close enough. It didn't give us units, so we don't know the units here. Okay, if you don't have one of the legs, if you have a right triangle, you know the hypotenuse and one of the legs, you're going to do it like this: a squared plus 10 squared equals your hypotenuse squared. So you have a squared plus 10 times 10, 100, 12 times 12, 144. To solve this, we need to get a squared by itself, subtract 100. A squared equals 44, right? Take the square root. What's the square root of 44? 6.6333. Okay, so that would be the other side. It doesn't always come out to a perfect, beautiful number. Okay, how about if we have a square root in there somewhere? Let's say we have a triangle that has a 1 and the hypotenuse square root is 7. We want to find the other leg. We'll do 1 squared plus b squared equals square root of 7 squared. That's a good thing. We could just undo that, right? We could get rid of the square root sign. So that's just 7. B squared stays like it is. 1 times 1 is just 1. So to solve for b squared, subtract 1. You have b squared equals 6. So what is the square root of 6? 2.449?
2.450.
It wants to do it to 3 decimal places, so we'll leave the 49. If we were going to round it to the hundredths, we'd do the 5 there. Okay, let's start doing some applications. That was just reviewing the Pythagorean theory. Here, there's a problem with a baseball diamond. Okay, the baseball diamond actually has 4 right angles. Okay, even if I didn't draw it right, that it actually does. Okay. Yeah, it's never drawn right. A woman's fast pitch softball diamond is actually a square, 60 feet on one side. So every side is 60 feet. Okay. How far is it from home plate to second base? Okay, we'll call the bottom one home plate here. First base, second base. So how far is it from home base to second base? Home plate to second base. So we're going to use the Pythagorean theory, and this would be which part of it? The hypotenuse, right? Because these are 2 legs here. So we're going to have 60 squared plus 60 squared equals our c squared. 60 times 60, 3,600, plus another 3,600 equals c squared. So 7,200 equals c squared. What's the square root of 7,200?
5.